So I'm Jamie Allen. I'm the Senior Director of Global Solutions Architects. I have to read it myself because this just changed. I used to be in charge of professional services. I don't know if you heard, we purchased a consulting firm in the US, and now they had to put me somewhere else. So now I'm going to be working with customers who are doing POCs and stuff like that, proofs of concept, getting started with our platform, and I'm really excited about this because maybe I can get back into coding a lot more. So, my talk today is really going to be about what we're doing building services and what we need to do to build services that will be successful going forward. One of the things we found with people using our platform was that they could use Play Framework, they could use Akka, but nothing helped them build services that scale right off the bat. Nothing helped them do it in the correct way. And then we had to think about that. What does the correct way even mean? So we had a lot of philosophical discussions and arguments and tried to figure out how this should be done. And we came down to a set of really important rules that developers should follow. And then the whole idea behind the Logom framework was to build over Play Framework a way to create these kinds of services. So I'm going to be discussing a lot about these new ways of building services. So I don't know how much Gartner Group matters here in Italy. Does anybody here read anything from Gartner Group? There tend to be two types of people. There's the people who read stuff from Gartner Group, and then there are people who don't and don't want to. With Gartner Group, though, they had the ear of a lot of the executives in America and around the world, people who are trying to make decisions about how people do and build software. And Gartner is of the belief now that in the next 5 years, 50% of the applications that are being built need to be built in a completely different way, right? And that's going to get away from all the ideas of using things like a monolithic data store that does updates right in the database, right? And then you don't have any view of what happened before. So these kind of changes are really going to make a difference for us as application developers. So we have three things that I'm really trying to accomplish in discussing this talk. One, we need to make sure our teams are working faster. How many people here have been on a team where you were working on a project and you rolled out every 9 months, 1 year, year and a half? Anybody been on a team like that? And it's painful. Well, only one person, that's actually really good. How about just 6 months, right? Because you had to roll out everybody at the same time. And that kind of pain means that developers are always trying to make sure that all this coordination is happening between all these groups, and that means everybody's working slowly. Secondly, we need to be thinking about how we reduce dependency nightmares. And with dependencies, it's not just in code, but between these teams. What's going to make them work faster? And then also, one of the fringe benefits of these kind of architectures is even if it doesn't matter to you that you have the ability to work really high throughput with low latency and stuff like that, even if that isn't really fundamentally important to you, it does actually realize itself by following these kind of rules. So that's actually pretty nice, because who knows at what point your business is going to be slash-dotted. Anybody remember that? Does anybody even remember Slashdot? Okay, a few people. Yay, all right. Yeah, that was an old site that we used to go to, like Hacker News, that would allow us to hear what was happening in tech. And whenever somebody would put something up there, everybody would go read it, and then the site would go down every time. So it became a joke that you got slash-dotted. But you don't know when that'll happen to your business. And if you finally get that one chance when everybody wants to come to your site and see what you're doing, and you go down, that's bad, because you might not get it again. Now, I'm going to say some things that are actually pretty controversial during this talk. This one isn't so much that. First of all, I hate the term microservices. It says nothing. Very few people have a common view of what microservices really are. And so what I've been proposing, and nobody's listening to, is that we should call them isolated services, because size isn't what matters here. It's really that we build services that are completely isolated from one another and isolated in multiple dimensions. So let's look at what those are. There's a fellow in the US, his name is Ben Christensen. He's the creator of RxJava. He gave a really good talk that's now on microservices.com. And the first two bullet points on this slide are shamelessly stolen from him. First of all, we need to think about having our services decoupled at the API. If you're calling through a client to talk to something, it's giving you an API that you call through and then it does all the wire protocol and everything like that, you have a problem. You're now coupled to whatever version of that tool or service that's on the back end directly. And when that needs to be upgraded, you have to upgrade your service as well. This is why we started moving to things such as RESTful APIs over HTTP, so that we didn't have this problem quite so much. But we also need to think about isolation in our source. How many people are working on a project right now where you have a library called core or utils or miscellaneous or commons or something like that? How many people? Yeah, everybody. And I'll admit, I do this too. Because we are all taught that we should be not repeating ourselves. We want to be dry in our code. And so we say, all right, well, we'll just put this in core or commons or utils or whatever we call this pile of garbage. It's garbage, because what happens is you don't know where to put something, so you dump it in there. And how many people are, Scala developers with long builds? Anybody? Come on, it's not that great for a long build. It is, it happens. Well, how much fun is it when you suddenly have to rebuild for something totally unrelated to your project? This happens all the time whenever you have core or commons. And to make matters even worse, if you have a shared library inside there like Guava or, I don't know, whatever you could think of, anything Apache Commons, right? If you have something like that in there and you need to upgrade it, you now have to upgrade all of your other projects as well. And this can take months, years. Who knows how large a code base is? So why do we do this? We should be creating these shared dependencies only inside of a single service. If we say that we have a core or a commons inside of a service, I'm totally fine with that. But if we have it in multiple services, now we have spaghetti dependencies. And that's going to cause us a lot of pain down the road. And people say, well, that means that I'm going to have the same code in multiple places. Yes, you will. I'm saying to do that. Because if you do, what is more painful? Having 3 representations of the exact same logic in your code, or going through an upgrade cycle that takes a year and a half? I'll take the 3 examples of the same code. Call me crazy. And then we also need to think about our data. We cannot build services that are going to use data from the same source. They have to own their data. They cannot have multiple services trying to get to or change data in the same repository. Mind you, you can logically split data. You see this in Cassandra using key spaces and stuff like that. And if you do that, then that's fine. You can have one Cassandra cluster up and running, multiple key spaces, and you've logically isolated your services. But what you really want to make sure you do is not create that one database that all the services are hitting. Because then when you have to upgrade the schema because of one service, you have to upgrade all the other services as well. And that's painful. So don't do it. We need to have our services have isolation. They must have ownership of their data. So this here is a picture of the Titanic schematically, sort of schematically. And you see here, it did have bulkheads. They didn't go all the way to the top. They knew when they built this ship that bulkheads should go all the way to the top. But someone made the decision that they didn't have to. And whenever their gash occurred in the front of the boat, the water started leaking into the front compartments. And that meant that the ship started to tilt downward, which meant that the water spilled over the bulkheads. And it tilted more, over more bulkheads, tilted more until it went down. Now, hopefully that isn't an analogy for what happens for our software. But it shows you that even when people know the right way to do things, we still sometimes don't. And it can result in, well, hopefully not 1,400 lives lost. But still. So another thing I'm going to say that is really annoying to some people and maybe a little controversial is I hate data fabrics. These things are becoming the bane of my existence out in the field. How many people are using a data fabric? And it's not because I don't like Apache Ignite and grid gain or well, I don't like coherence. But the ideas were really good. But then instead of just having data in memory, we ended up with this idea of shared data and it was really mutable state. If somebody really went to the level of having a fabric that was immutable data or that only one service could change, maybe I'm okay with it. But nobody does this. So inevitably, data fabrics become this large, shared, mutable state with its own locking and replication that's killing your performance. So we don't do these sort of things. We need to move instead into the idea of following the rules of CQRS, Command Query Responsibility Segregation, where we're saying that we're going to have a read store and a write store. Two different stores. Yes, that is more operations work. But you know what? We have data immediately captured in a way that is quickly written out. And we also have data that is consumable in a form that allows the people who need that data to use it immediately. It's just we have to do something in between to get the data from the write store to the read store. I'll talk about that in just a little bit. Event sourcing, when you look at the traditional monolithic relational database management system, say you're using Oracle or something and you're using a relational model, you're updating state in place. You're changing it inside of the database as you're working. And now you've sort of exported locking and everything over to the database and let it figure it out, because that's what databases do, right? But look at the people who are DBAs. Anybody here a DBA? All right. How many people know a happy DBA? Has anybody met one? They're always upset. And it's not because they're bad people. They're not. They're great. Unfortunately for them, they're stuck in a really bad position where they have to help people put stuff into the database really quickly and read from it really quickly. And these two jobs are at odds with one another. So they're always making trade-offs. And they're always being yelled at for not doing what you want well enough. It's not their fault. They're working in this world of compromise at all times. So DBAs, this will make their lives a lot easier. They can take a database and make it really write performant, but maybe it won't be so fast on the read side. Or vice versa. They can make it really good for reads, but then the writes are really slow. Now they don't even have to think about that. And you know what? They're still valuable people because they have great ideas about how to make things work fast in the data world. So it's not like we're just going to say, well, get rid of them. First of all, I'm going to talk about Spring JDBC. I hope nobody gets mad. How many people have used @transactional? Worked pretty well, right? If you're going to sit there and write to multiple tables and one of the writes fails, you roll back. What did we do whenever @transactional failed in our code? Anybody do anything? No. So what happened to our users? They'd see a 500 error, right? And we just say, oh, whoops, that's not good enough, right? We've got to do more than that as developers. We have to make sure that we have an experience for our users that says, you know what, I tried to update 2 out of 3 tables or whatever, 2 out of 3 stores. And you know what, the third one didn't work. But that doesn't mean I shut down everything. Instead, I sit there and I retry, possibly with exponential backoff and stuff like that, always bounded within time and space. Because everything you do asynchronously has to be bound in time, like I'm going to retry it for a minute, and space. I'm going to retry it maybe 5 times. I'm going to see if that works. And if it doesn't, I'll have an escalation procedure inside of my system for what I do in these situations. Maybe it is a notification to somebody who says, oh, I've got to resolve this one thing. Who knows? But it's all domain specific. And now all of a sudden, your failure management inside of your system becomes domain events, right? This is really important. We're great at modeling all the things that can go right in our system. We're terrible at modeling all the things that go wrong. And believe it or not, they're just messages. If we get away from the idea that exceptions are these runtime things, they can be just messages. And you see this inside of Akka. So consistency, we all know, is an anti-pattern at scale just because of things like the CAP theorem. You have the choice between consistency, full consistency, or full availability in the face of network partitions, right? But it's a sliding scale. Nobody goes for full consistency, except, 1 or 2 database vendors who are really looking at changing their way of going about this, by the way. Nobody wants to be totally available and never consistent, right? They want to have some consistency to their data when it's replicated across multiple nodes. So it's a matter of finding what tools help you meet your goal of eventual consistency. And things like distributed locks, I mean, those are they just make my head hurt. They do. The idea that I'm going to have data replicated in multiple places, I'm going to update over here, so I'm locking, and you know what? Suddenly I get a network split, or I get that machine fails while holding the lock. Anybody ever run into those kind of fun things? They're no fun. They're horrible. So why are we even trying to do this? We get talked into these things by vendors. I know, I'm a vendor too. But, if we just sit down and think about the implications of these kind of thought processes, they never make sense. It's like people who sit there and say, we do exactly once message delivery. Really? All right, let's talk about this and find out exactly what asterisks you're throwing on top of that, because it really doesn't exist that well. Like Flink right now is claiming exactly once semantics, and I really have to sit down and read this white paper they put out, because I don't believe them, because exactly once doesn't exist. There's at least once. The idea that I'm going to resend until I find out something was done. Then I have a guarantee of delivery. But exactly once that I send it one time and it was handled, how often does that really happen in the face of all of the things that can go wrong in this world? Network splits, machines failing, bad code. Not that I write that. I really like this quote, by the way, and it's largely inspired by Martin Fowler in his microservices blog post. But this is one of my coworkers, Kevin Weber, and he says, think in terms of compensation. Don't think in terms of prevention. You never know what a piece of infrastructure will do in your system. You never know that it's going to do everything it says it will. So how are you going to deal with the fact that that might happen? If you put something into a message queue, is that message queue always going to deliver it? Do you know that? What if it didn't? Does that mean that you're not consistent anymore? And what does that mean to your business? How are you going to deal with it? Now, when we talk about resilience, we have to think about resilience in a completely different way. And this is where I'm talking about the whole compensation and not prevention. Because failure happens at so many different levels. It can happen, on a thread. It can happen across nodes. It can happen across physical boxes. It can happen across data centers. Is anybody here using Netflix's Simian Army? Wow, not one. Okay, this is an amazing library out there. And one of the things I highly recommend is checking out a fellow named Peter Alvaro. Peter Alvaro is a newly minted PhD out of the University of California at Berkeley. Where Spark came from, where Mesos came from. He wasn't on any of those teams. But he sort of flew under the radar and at the same time was working on statically verifying before you went into production whether or not you had a system that would fail. And that's really amazing stuff. Well, Peter has been running around giving talks for a little while. He's going to be keynoting the Reactive Conference in Austin, Texas in October. Keep an eye on what he's saying because it's really important. And also, look at the Simian Army and how it is taking down nodes in production for Netflix. While you're sitting around watching Netflix, nodes are going down, and they're doing it to themselves. And they're doing it in production. Isn't that crazy? And yet, that's how they know that they can withstand anything. They take down entire availability zones, the virtual equivalent of a data center, to see whether that impacts your viewing experience. And it doesn't. How many people have seen Netflix go down recently? It's been years since they had one of those outages that everybody was complaining about because they're always testing this. They are fanatical about making sure they are up and running at all times. So this is also going to be slightly controversial. I deal with customers who work at a really high scale, and one of them is PayPal. PayPal has 1,700 services in their architecture, and they run on over 100,000 VMs. That's just huge scale, right? Just think of all the payments they're doing around the world. And that also is a really big bill when you think about it, a lot of money you have to pay to stay up and running. But when you have that many services, do all of them really have to have an HTTP RESTful API? Because that is an expensive concept. Not expensive in terms of threading models, right? I'm not talking about synchronous threading models, but it is a synchronous interaction of request and response, right? Involving a connection. And that can be heavyweight over time, over space. So what if instead we started thinking about only the services that require that kind of decoupling, and then other services can have interactions via streams or via messages? I like to give this example. Imagine I had a service for customers. And this is going to be a pretty extreme example because I'm going to have services behind my customer service for addresses and another service for phone numbers. And that's because I might have another service out there like businesses or something that also consumes addresses or phone numbers, right? Well, the customer could have a RESTful over HTTP API. But does the connection back to the address service have to be RESTful? Does it have to be over HTTP? Couldn't it just be a message? Couldn't it be if it's not a request response semantic, if I'm just feeding data in, why isn't that stream? And if I do require responses, that's where I might want to use messages. But at least then, I'm not going to the same level, especially in my code, over a socket. It could be local. That's nice. Now, this one's a little unrelated to my talk so far, but if you think about all the things that we want out of our services, we must use immutable deployments. We have to be using tools that thumbprint, fingerprint, whatever you want to call it, the artifacts that we are putting out into production so that we know exactly what the source or the binary is, but also, the configuration, all wrapped up in a single artifact. And you know exactly what it is, and it's spread out across all our boxes. This is what allows us to run multiple versions at the same time because we have clear assurances of what a version truly is. And if somebody tries to go in and change that configuration in production, does anybody know anybody who's ever done that? Because, sometimes somebody says, go out there, fix something because we got to get the server back up and running. Well, all of a sudden, you have no idea what you're running on all your boxes. That's bad. Immutable deployments will help with this tremendously. And then when we think about our services, we only expose our API, our endpoints, or whatever, all the complexity that we write behind them, such as that customer service. The fact that I was calling out to an address service and a phone number service was irrelevant to anybody using the customer service. We're keeping all of that complexity masked behind the service, and nobody consuming it cares. Now, how many people here use domain-driven design? Okay, a couple. It's a really great way to model your services. It's a really great way to think about how you separate your concerns, right? Like, you've got bounded context. And everybody says that whenever you're building your services, every one of them should be a bounded context, right? But if you haven't really read these books, then that sounds, what does bounded context mean? I like to think in terms of we need to solve our pain. We do not need to write services that are going to, follow all of these rules from books. They're really helpful when you're in a greenfield world. If you're starting from scratch, this will really help you decompose your problem. But if you already have a system in production and it's no longer able to withstand all of the load and scale that's coming at it, this doesn't help you quite so much. So instead, you need to solve your pain. I have a story I'd like to tell you about when I was working at a large cable company in the United States. They have 40 million customers, or at least they did back in 2011, 2012. And they used to have a JEE application that handled all of the customer requests that said, I want to be able to watch HBO, Game of Thrones or whatever. They would call up and some operator would receive the call and they would then say, all right, I'm going to enter that in for you. And it would go through a JEE app and go back to a monolithic relational database management system, Oracle. And it worked great. And that system was built in like 2000, and it worked for years, and everybody was really happy. But then along came on demand. How many people here like on demand, watching TV on demand? All of us do, really, right? It's great. You're no longer bound to the time that a show or a movie is on. So you wait until you have time, and then you watch it. Awesome. Around 2005, 2006, on demand started to hit. But, there wasn't much content out there. So it wasn't a really big problem for us. And then around 2010, well, there was a lot more content available on demand. And every single one of those clicks that you're doing on your remote is a web service call, going back to a database, trying to figure out what you have an entitlement to watch. Every single one of the cable operators out there has to manage your entitlements as a customer. And we were running into this really early because of the scale of our operations. We were the largest cable company in the US. So we were no longer able to work with this single database in a JEE application where we were doing all of the writes based upon people calling up and saying what I want to watch, and all the reads because of all the on-demand content that people were trying to consume. So we knew we had to split entitlements out of our existing system. And when we did, suddenly we were now thinking in terms of CQRS, even though it was a legacy system. It was an Oracle database, became a write store. Whenever somebody wanted to change what they were watching, we updated that database. We could denormalize the data in the database and make it so that we just had accounts, customers, channels, all of that, and the relationships between them were unimportant. Now, mind you, did we actually do that? No, because it was such a big scheme of change, but we could. And that allowed us to free up all the indexing and stuff that we were doing on the fly. It was really hard, right? We could get rid of that, but we didn't completely change the database. We could if we wanted to, if we had to. Now, on the read side, we've got to make that data consumable through a service. Some service has to exist out there that's going to allow all of the people out there trying to see what they can watch at a point in time to get that information really quickly. And that meant we wanted key value semantics. We wanted the key to be the account ID and the value to be all of your channels you could watch. Or maybe the MAC address of the device you're watching from, your computer, your tablet, your set-top box, whatever. But that MAC address to all your entitlements. And that meant we were duplicating data in multiple forms. Yes, having the same data in multiple buckets inside of our database. And we were totally fine with that because it meant it was easily consumable in our read view. But now we've got a problem. We've got the write store over here. We've got the read store over here. How are we going to keep them consistent? And we thought about this. We said, well, what if the Oracle database emits an event, and that event gets captured by something which puts it into RabbitMQ, and then RabbitMQ can have a whole bunch of people subscribing to the topic to do a bunch of conversions based upon data from the database and from some files that we were getting regularly, and do the conversions and stuff like that, and put it into Riak. Riak was the key value Dynamo-based store that we were using. Really, really good tool, by the way. And we thought about that, and we said, oh, that's good, but what happens if something fails? What if, we don't get the event out of Oracle? What if we fail to put it into RabbitMQ? What if RabbitMQ does not push that data out to the, through its topic subscribers? What if the subscribers fail? What if it doesn't get into Riak? Well, that's all based on time. And if it doesn't happen at the time of the event, it never will. How are we ever going to recover from that? And more importantly, are we going to know if that happened, if it went wrong? And now our read store could theoretically be out of sync with our write store indefinitely with us not knowing at all, except customers calling us up and saying, I can't watch what I want. So that's a problem. Instead, what we did was we architected it so that we were always recalculating your entitlements. Get all of the accounts, get all of the customers, get all of the channels, get to see if there's any of the other data that we needed coming in from other sources, and then recalculate everybody. When we're done, do it again. When we're done, do it again. Never stop. And now you have a tunable view of the eventual consistency between the two databases. And by doing that, now we never had to worry that we were out of sync. because it would always self-heal. Now, the hardest thing to think about when you're dealing with these kind of cache databases is deleting, because deleting is extremely expensive. So if somebody said, I don't want to be a customer of this cable company anymore, we don't want them to be able to still watch channels. So we've got to remove them. And that's easy to do from the Oracle store, but how do we do that from Riak? And it turns out you don't have to. You can let Riak have its own sessions, and whenever you define what those sessions are, if that data is not updated again, it tombstones it and gets rid of it. And you don't even have to think about that. And it's like, wow, that just made my life a lot easier. That was code I did not have to write. Win, right? So when we think about solving our pain and we apply these kinds of concepts, suddenly things fall into place actually very easily. But don't get sucked into the idea that everything has to be time-based. Because if it is, you're going to be in a position where you're losing stuff somewhere and you may not even know it. Okay, so this is something Jonas, our CTO, has been running around talking about recently. Has anybody heard of this, the whole idea of ACID version 2? There's the old ACID, the old and busted, like from Men in Black. Anybody ever see that movie? They'd see this old cruddy-looking car or something like that, and Will Smith would make fun of it, right? Old ACID was atomic, consistent, isolated, and durable. Well, those things don't matter so much in a distributed context. Instead, we need to start thinking about associativity, that we don't care how data is grouped. Because if we don't care how data is grouped, we don't have dependencies between data, right? We want commutativity, which means ordering is not important. Like 2 plus 3 is the same as 3 plus 2. It doesn't matter the order of the operands, I get the same result. That's really important. And if we have associativity, where we have no dependency between data, and we have commutativity, where we don't care about order, well, now we have linear scalability, because we have the ability to start up more nodes to consume work because they don't have any dependency between them. And then that's true scalability. But not every problem falls into this world. And then when you have to give in and you have to have grouping between data, just accept the consequences that it's really going to kill your performance. It is. This is Amdahl's law at work. A single % of coordination between two what were linearly scalable tasks before, just 1% of coordination means that you have lost 60% of your efficiency. Mathematically proven. That's not a theorem, that's a law. Right? Not that theorems aren't actually true as well. Anyway, we want idempotency. Think in terms of those messages that we're sending. If we have to send it 5 times before we get an acknowledgement that it was handled, well, we need to know that we're not giving somebody $100 in their bank account for every one of those messages, right? That would be bad. These sort of things do come from monotonically increasing IDs for our messages, but really, isn't it better to have your logic be able to deal with the fact that, I'm not going to update that 100 times without checking some ID? We'd love to have those semantics. It's not easy to do, so we end up falling back to those monotonically increasing message IDs. And then we want distributed data. We need distributed data. And then you have to make choices. Are we going to shard data such that, A through G is in one box and, H through L is on another box, you know what I mean? Or through consistent hashing. Or are we going to go with replication? And if we've got replication, how are we going to know that if updates are coming into both or 3 of them at the same time, which one has the current right answer? That's tough. And those kind of problems I really like to export off to Dynamo stores like Riak and Cassandra, because they do it a lot better than I do. But there are some tools that we can use for this sort of thing, like Akka distributed data, which is using the exact same concepts under the hood. That's CRDTs, conflict-free replicated data types. And using that, we can have 2 representations of data across multiple actors in, different boxes, both receiving updates, and always know what the current answer is. It's not free. It comes with cost, because every time you need to make guarantees in a system, you're going to pay a cost. You just have to figure out how big that cost is, and is it worth it to you? For example, that cable company thing that I was talking about before, our cost was in footprint. We were always going to be running this service that was always recalculating people's work. And in doing so, it wasn't like some simple little thing that was only doing a couple transactions a minute or something. Instead, it was doing everything all the time. More footprint, but for the business value, it was really important to them. Okay? And, the caveat here is, if you're going to do this sort of thing, there will be additional complexity. And that does kind of suck. I mean, let's be honest here. You're going to be deploying a lot more stuff. But at the same time, you'll be deploying them independently of other things. So that's a plus. Just know that you're going to have to manage all of this, all these extra databases and storages, and you're going to have all these extra services that are all running independently. They're all going to be running on boxes. You have to figure out, are they going to share boxes or not share boxes, things like that. It's not free, but it's worth it. So, now we get to logum. And I've spent a lot of time trying to work on how I pronounce this. It's, if I'm correct, it is logum. Logum. And if you listen to it on Wikipedia, it even sounds like with this really deep voice, But, when we were sitting down and trying to come up with a framework, first of all, one of the tough things is you have to come up with a name that's not being used by everybody else. Because that's always one of the really tricky things. If somebody has the same name as what you're doing, then you have this mental overload of trying to figure out, are they talking about that or this? And that's hard, right? So we first found out that nobody was using this word. But what was really important to us was that it meant something. In Swedish, it means just the right amount. And instead of thinking in terms of microservices being small or anything like that, it's just build what is right for what you're trying to accomplish. So, logum comes with 4 distinct things, right? It's got a service API, a persistence API, a development environment, and then a production environment. And you may think it's weird that I'm talking about what is a Java thing here at a Scala conference, but believe me, every single one of the developers at Lightbend really wants to get that Scala API in there now, right? We have to make sure that Java developers are set up first, because we made this mistake in the past. Play Framework, we bought it from Zenexity in France, and then they became Zangularity, and when it was originally a Java framework, but Play 2 was pure Scala. And then we had to put a Java API on top of that, and that was really hard to do. Really, just in the last 6 months, would I say that the Java API is now at parity with the Scala API. It's hard to believe, huh? Because we've been around 4.5 years. And look at Spray. Spray was Scala only. There was no way to take that and make a Java API for it. That's why we had to build Akka HTTP. So, when we looked at doing logum, we had to say, well, maybe we should do Java first. And believe me, there's a lot of haranguing inside of the company. No. And then there were ideas like, well, we really should support Maven. Oh, no. But think about it. If this is going to be working for Java developers, that's really important. But we couldn't make it work. Like, you just can't rail on SBT all you want. I won't blame you. But if you have to build something that's really complex, having the power of something like SBT is a lot more useful than trying to do it in Maven. And we gave up. I mean, we tried for a while, and I feel really bad for Mirko, who was stuck trying to figure this out for the longest time. Brilliant developer, couldn't do it. Not because he's a failure, but because this is something that just can't be done with Maven. So, oh well. So we will have a Scala API, and for what it's worth, you can develop Scala services with logum. You can do it. It's just, the Java API is there, and you've got to use things like Java conversions and stuff. Okay. So the service API itself, right? We want to make streaming a first-class concept inside of it. We want to make sure that you don't always have to use, HTTP RESTful services. And we also want to make sure that people are thinking in terms of bounded context if they can, right? Following the ideals of domain-driven design. They're baked into logum, even if you don't know you're doing it. That's kind of nice. The persistence API means that we're actually rolling this out with Cassandra embedded. For testing, there's an in-memory Cassandra. And then for production, you're rolling out there with Cassandra. And now you're doing event sourcing with Cassandra replicated across multiple nodes. And that means that you're no longer getting away with using a single monolithic data store. So that's really critical. And now you're getting away from having any of that, anybody ever use TopLink, Hibernate, JPA, all that stuff? You're never thinking about it again. And you always have the ability to replay your data because nothing is mutable in your data. It's always immutable. That's so critical. People say, well, I can recreate stuff using my audit log in my relational data store. You ever try it? Not easy to do, so give it up. This is a much better way to approach things. And don't get me wrong, not everything has to be event sourcing. Not everything has to be CQRS. We're pushing you in that direction, but you don't have to do it all the time. There are times when a relational store might make a lot of sense. So, there's a development environment. One of the great things about Play was the idea that you could sit there and hot reload and stuff like that. You get that with Logum as well. You will have the ability to say, I'm going to save my code. I got it. I'm going to save my code, and it's automatically deploying to the test environment with the Cassandra store and allowing you to run tests right away. So you no longer have to sit there and worry about all the operational management of multiple nodes with multiple services all being updated. It's all being taken care of for you. And then in production, this does involve our reactive platform and the commercial stuff, but it's pluggable. You can use Kubernetes. You can use other tools instead. That's fine, right? We do want to try and make some money somewhere. Pardon us. But the idea is to use things like our conductor tool to do the bundling of all your artifacts and push them out to all of the different, boxes that you want to run on, virtual or physical. And the great thing about that is you just say you want 3 of them out there, done. It knows its footprint. It'll put them out there somewhere. And it has the ability to do things like locality, affinity for where things should be relative to other things. So that's really nice. And then you don't have to think about service location, proxying, all those hard things. And by the way, when it comes to proxying and load balancing, you're going to need hardware load balancers. But they only know what physical nodes are up and running. You're also going to need a load balancing inside of your application level as well, right? So that when nodes go down, it knows where the application physically is. What if a JVM goes down on one of those boxes? Should it still be receiving messages? No. So allow for application level proxying and load balancing as well, not just the hardware. So some links here. There's the project site at lightbend.com/logum, and then the GitHub repo. There's also an activator template. And just as a really quick example, I don't have a lot of time, and I want to give people a chance to have questions. This is what your build starts to look like. You start defining projects, and they have links to other projects, right? And once you do that, now to start up, all I have to do is say run all. And it's going to deploy the application with all of the services and a Cassandra database at the same time. And as you can see, like with SBT, it's always fast, right? But it is coming up and running. It's deploying a whole bunch of artifacts, right? This is pretty cool. And then you could sit there and start hitting these IP addresses and ports and seeing what they do. So anyway, give it a try. Let us know what you think. Right now it's an MVP. I'm not saying to go out there and start running production applications with this yet, but we need your feedback, and also we need people to start building stuff around it. So, and that's it. Any questions? Who needs coffee? Deb or wherever, yeah. Does anybody have any questions? I'm available. I'll be here all day. But, yeah, thank you.